Pataways IPC class. We're looking at page 21 in your packet. You need to pause this and get your stuff. You need a couple of colors, you need a pencil, and you need your periodic table. So get all your stuff together. Pause this whenever you need to. So I'm looking at page 21 and I have my periodic table out. You should have a periodic table that looks something similar to this. And page 21 says you're going to fill in the chart for each element listed following the prompts at the top row. One thing that's not in here is drawing out the Bohr model of the atom. And what we're going to do is we're going to take this and do that first so that you have a better picture of what the atom looks like. So calcium is on the periodic table here. It's number 20. And notice that it's in period 4. What that means is it has 4 orbits. 1, 2, 3, 4. So I'm going to use the symbol here as my nucleus, and I'm going to draw 4 orbits. 1, 2, 3, 4. And now I have to place those 20 electrons. The first orbit can hold 2 electrons. The second orbit holds 8. There's 2, 4, 6, 8. Now, out of the 20 electrons, I've placed 10 of them. The third orbit can hold 18, but it's only going to hold 8 to start with. 2, 4, 6, 8. And then before I finish filling that one up, I jump to the outermost orbit, and it can hold up to quite a few electrons, but we're going to put our last ones in here. So I've got 2 plus 8 is 10, plus 8 more is 18. I have 2 more electrons to place, and I'm going to put them in the outermost orbit here. So now if I look at my periodic table, here's calcium. I have 4 orbits, and if you look up at the row, at the group where calcium is in, they have 2 valence electrons. So 2 electrons in the outside orbit here. So that's what calcium is. Now once I have that drawn, I can look here and I can say, oh, how many electrons are in the outside orbit? 2. So a number of valence electrons, 2. Or I can look at my periodic table and I see here's calcium, go up to the top, it's in group 2, it's got 2 valence electrons. Next one says draw the electron dot diagram for this, and it's really, really, really simple. So to draw the valence electron dot model, I write the symbol, and again, it has 2 valence electrons, I put 2 dots. Will it gain or lose electrons to bond? Okay, if it gains or loses electrons, it's all about the magic number 8. You wrote on your periodic table the magic number's 8, right? For some reason, when it's got 8, that's when it's great here. That's when it's stable. Calcium has 2 valence electrons. And if I pop off those 2 valence electrons, look down here, 2, 4, 6, 8. The next one in has 8 valence electrons. So calcium is actually going to lose its valence electrons, and it's going to lose both of them. And then when it does that, instead of having 10 positive protons, instead of having 20 positive protons and 20 negative electrons, I only have 18 negative electrons. So I've got positive 20 and negative 18. I get a plus 2, so I have a plus 2 charge on that. So what I'd like you to do is drop down here and go through, and the first thing you need to do is make the Bohr model for these atoms. So let's do chlorine. So here's chlorine, and I find chlorine on the periodic table, and it has 17 electrons, 17 protons, 17 electrons. So my first orbit can hold 2, always and only. My second orbit can hold 8, 2, 4, 6, 8. My third orbit, I'm going to put 8 of them in if it's got it. So I've got 10 placed, but I only have 17 electrons. I've already put in 10, I need 7 more. So 1, 2, 3, 4, 5, 6, 7. How many valence electrons does chlorine have? Well, go to the outside orbit. How many electrons? There are 7 there. And you can also check your periodic table. Here's chlorine. Go up to the group it's in. It's in group 17. Cover up the 1. And it has 7 valence electrons. So we have 7. How do I draw the electron dot model? Well, I write the symbol, and I've got 7 valence electrons. I can fit 2 on the right, 2 on the left, 2 on top, and I can fit 2 on bottom, but I only have 1 left, so I'm going to put 1 of them on the bottom. They don't fit in a little circle, so if you draw it like this, that's just wrong, okay? So 2 on top, 2 on bottom, 2 on left, 2 on right. So that's how they can, those are the positions that they can fit into. Notice how the magic number's 8, right? It can hold, look, it's close. It's got 7 valence electrons. It only needs 1 more to get to that magic number and be stable. It's actually going to steal an electron from somebody. So it's going to gain an electron. How many does it need to get to 8? It needs 1. So now chlorine has 17 protons, and now it just stole an electron, so it's got 18 electrons. That's a -1 charge. A -1 charge here. So that's what the charge is on here. Draw the Bohr models for each one here. Find out how many valence electrons. Draw the Lewis dot model for these 3. Tell whether or not it's going to gain or lose electrons. If it's closer to 8, it's going to gain electrons. It's going to steal them from somebody. So anything over 4, it's going to steal electrons. If it's less than 4, it's going to give away those electrons. And what's cool is that if you look at your periodic table, all the metals, they're always going to give away their electrons, and the non-metals are always going to take them. They're going to gain electrons. So if you can look at this and determine is that a metal or a non-metal, then you know whether it's going to gain or lose electrons. Let me say that again. All the metals, the yellow here that I have on here, they're always going to gain they're always going to lose electrons. The non-metals are always going to gain electrons.